Alright, so we're going to go ahead and look at the diagram that we're given. So they're telling us that GB, this line here, and GD, they're telling us that those are congruent. We're trying to then prove that angle B and D are congruent. Now, if you notice the theorems that we've been going over, we've had triangles to compare. Right now, I only have one triangle here, but if we go ahead and create an auxiliary line, which we've talked about, it's when you create a line to help you prove a construction. So what you're going to do is you're going to draw a perpendicular bisector. Make sure that you're doing the construction. Okay, so when you're doing that, I need to see the construction happening. I'm going to go ahead and construct mine. So here's my perpendicular bisector. When you draw this, be sure to make sure that you are actually doing the construction. I'm not going to go ahead and waste time with that because you should know if you've been watching the videos. Alright, so right now I know that this side, and I'm going to label stuff that I know that this is congruent to this because that's given to me. So my reason for saying that GB is congruent to CD is because that is given. Now from there, I'm going to go ahead and say that I have my auxiliary line. So I drew an auxiliary line which was a perpendicular bisector, and the reason is because I did a construction. So that's my reason for making that. And then I'm going to go ahead and call the midpoint of DB point C. So that's why I have point C here. Okay, so I'm going to go ahead and call that C, which it's already labeled. But you're also going to want to make sure that you give a reason, which is that every segment has to have a midpoint. Okay, so that's our reason for putting that midpoint there. Once we've gone ahead and set that, we can go ahead and start saying that now BC is congruent to DC. And I'm going to go ahead and mark that in my proof. So BC is congruent to DC. I'm putting two little line segments for congruency because I already used one earlier. And the reason that we can say that those two are congruent is because that's the definition of a midpoint. So when you have a midpoint, you're basically drawing a point right in the middle between the two. So far I have two sides that are congruent, and I can also say that GC is congruent to itself because of reflexive property. So we've known these are the properties we've gone over. So now I have the third thing being congruent. So let me go ahead and mark that. So now this time it's going to have 3 marks because that one's congruent to itself, not to the other ones. So now the fact that I've already have 3 sides that are congruent, we can now say that triangle GBC, okay, this triangle here, is congruent to triangle GDC. So this triangle here, right? And the reason for that is because of side, which we've gone over. Now, because these two triangles are the exact same triangles, I can now be able to say that therefore angle D and angle B, which is what I'm trying to prove, I can now say that those two are congruent. And the reason for that is because of the CPCTC, because of the corresponding parts of a congruent triangle are congruent. So that's what that acronym stands for. As soon as you tell me these are the exact same triangles, you can then say that every single part of these two triangles are going to be exactly the same. So for example, if you've proven that these triangles are congruent by side, and then you told me this angle here is congruent to this angle here, and I said why, you would tell me CPCTC, because again, now that these triangles are the exact same triangle, every single part that is corresponding to each other will be congruent. Just like this one, which is a right angle because of the perpendicular bisector, will be congruent to that angle there because of CPCTC. So now for the next proof, you guys are going to go ahead and prove that one. I'm going to go ahead and give you these choices. Make sure you match the statement and the reasons where they correspond correctly. And make sure to skip number 2A. You are only doing 2B. So now we're going to go ahead and talk about the special right triangles. We're going to talk about the 30, 60, 90. So now let's go ahead and take a look at number 1. They're telling you that this is an equilateral triangle constructed in the diagram. A perpendicular bisector of AB is also constructed, and which means that which intersected AB at point D. Remember, perpendicular means you have right angles. Bisector means cutting in half. So cut in half. And then over here, equilateral means that it's all congruent. So they're asking, how do you know that this triangle here is an equilateral triangle? And you should be able to notice that they've asked us this question before a few units back. So if you have to look at your notes, do so. But they've asked us this question. So make sure you're using what you know about the circles, about any part of those circles that can help you explain that. Now move on to B. They're going to tell you, so because we have this, remember this is an equilateral triangle, which means that this, and this are all 60 degrees because of the equilateral triangle. Now they're asking you, how do you know that this triangle, CDB, this one right here, how do you know, and I moved, it's over here, how do you know that that is a 30, 60, 90 triangle? Again, use what you know about the circles, use what you know about any information that was given to you on A, which is the like perpendicular, bisectors, all of that stuff, and then go ahead and tell me how you know that that's a 30, 60, 90. Then you're going to go ahead and skip C and D. You're also going to skip number 2. And then for number 3, you're going to go ahead and write this down. They're going to ask you to label the side measures. This is the 30-60 triangle we were talking about. Go ahead and label the hypotenuse. Remember that the hypotenuse is always the one that is opposite from the right angle. So the hypotenuse will be called 2a. The short leg will be a, and the long leg will be a square root of 3. Now these are the formulas that you need to make sure you know how to use them. SL means short leg. LL means long leg. And the H means hypotenuse. I just didn't want to have to write it over and over, but if you want to, you can. But I also put them here in parentheses so that you guys can reference them. All right, now we're going to go ahead and move on to the 30. Well, that was a 30, 60, 90. We're going to go ahead and move on to the 45, 45, 90 triangle now. So now they're telling you to consider this isosceles right triangle constructed in the diagram, and they're telling you that MP is a perpendicular bisector of QN. So again, perpendicular means right angles, bisector means you're cutting something in half. So they're telling you, explain how do you know that this triangle here is an isosceles right triangle. Remember that an isosceles right triangle means that you have at least 2 sides congruent, the 2 base angles are congruent, and that you have 1 right angle. So tell me, how do you know that this is an isosceles triangle? Again, use what you know about circles to be able to prove the isosceles part, and you should be able to prove the right triangle part by looking at the picture and explaining where that right angle came from. Don't just tell me it's a right angle. Where did it come from? And then they're telling you, explain how you know that angles PMN and PNM are congruent angles. So you're going to go ahead and tell me, how do you know this angle here is congruent to this angle? Again, think back. What are the 2 things I told you are always true when you're talking about an isosceles triangle? This is also something we learned from a past unit. You're going to skip 5. And then you're going to move on to 6 here. Again, label this one. Now you have a 45, 45, 90 triangle. This time the hypotenuse is a square root of 2. And this time there is no long leg, there is no short leg. These are actually congruent. Go ahead and add this to the picture. I forgot to include it. But these 2 sides are congruent. On the 30, 60, 90, you do not have any congruent sides. But on the 45, 45, 90, you will always have congruent, 1 pair of congruent sides 100% of the time. And then these are the formulas that, again, you have to know how to use them over here, the hypotenuse and the leg. So for now, that's where we're going to go ahead and stop. We will actually apply these formulas on Monday, but you do need to make sure that you have these notes ready. Make sure that you answered all the questions on Edge Elastic and that you are actually watching these videos and taking notes. Like I said last time, the notes that you're going to be getting off of my videos are going to start counting more than the ones that you do on your own.